All right. So here we'll be discussing about the length of a circular arc. So if you have an angle whose radian measure is theta, subtended by an arc. So what is an arc? An arc is just a fraction of what? The circumference. So if you have a circle and this is the center, so you have an angle, right? This is radius and here is your theta. So the distance from here to here is what we call S, which is the arc. So the length of an arc, as you can see, this arc is just a fraction of what? The circumference. So, and this depends on theta, right? So that is why we have theta over what? 2 pi times what? The circumference of the circle. But what is the circumference of a circle? It's 2 pi r. And you can see 2 pi will go with 2 pi. So you just have r theta. In other words, if you want to find the length of an arc, you just use S is equals to r theta. But what to note is that here, the theta is in what? It has to be in radians before we use this formula. All right. So if your theta is in degree, you can just convert it to radian. So let's see this few examples here. It says find the length of an arc with radius 10 meter. So the radius is 10 meter and the angle is what? 30 degree, which is nothing but pi over what? 6 rad. Right? So it means S is going to be r theta. So this is just 10 times pi over 6. And this is going to be 5 pi over 3. And this should be meter, the same unit with the radius. A central angle theta. So let's just have something like here, what we're, you can draw this one. This means the radius is what? 10 meters. And pi is what? Pi over 6. So this is our S here, which is this length here. So this one says a central angle theta in a cycle of radius 4. So you have a cycle of, let's say, radius 4 meter. So we're actually looking for the theta, right? And we're told that the length, the S here, is already what's the arc of length 6 meters. All right. So simply, we're looking for theta in this case. We don't know what is theta. So S is equals to r theta, means that theta is what? Is S over r. And this will just be what? 6 over 4, right? So it's just going to be 3 over 2. Now it's going to be radian, our theta. So example 10, let's see. Says if the length of an arc which subtends a central angle of 40 degrees is 6 pi centimeter. So in other words, here we have the theta is given 40 degree, which we can write as 40 times what? Pi over 180. So this is going to be 2 pi over 9 rad. And S itself is what? Is 6 pi centimeter. So we are looking for the radius of the circle. So S is equals to r theta. And this means that what? R is equals to S over theta, right? So what is S? S here is 6 pi divided by theta is 2 pi over 9. And this is just going to be 6 pi times what? 9 over 2 pi. So this and this will go, will give you 3. So we just have 27, right? Yes, so R is going to be 27. And that is in centimeter. So finally, example 11, it says find the measure of the central angle theta. So here also it means we are looking for theta. The diameter is what? 12 centimeter, right? But we know that diameter is equals to 2r. So the radius is going to be diameter over 2, which is going to be 6 centimeter, right? And what else do we have? S is also 7 centimeter. So we know that S is equals to r theta. So theta is S over r, which is simply equals to what? What is S? S is 7 over r is what? 6. So this is theta, and the unit has to be in radian. Okay. All right, so let's talk about circular motion. Circular motion is saying that suppose you have a what? Let's suppose you have a point that moves along a circle as shown in this figure, right? There are two types of motion that describes the motion of the point. So let me just explain it here. If you have this, let's say you have a point on the circle. Now, the distance from the center definitely to this is your radius, right? So let's assume we want to move this point. If we are moving this point from here and we are shifting it here now, so you have to cover a distance from here to here, right? And the more you move, the more the angle will change, because there's going to be an angle here. There have to be a terminal position. So if we keep moving and we stop here, what happened? The angle will also change. So if I continue, remember this is our starting point, and we keep moving, the angle will keep changing. So two things are changing: the linear distance from here to here, and also there is an angular change because the theta will also keep changing. So we have what we call the linear speed and the angular speed. The linear speed has to do with what? Has to do with the change in the length. So we have v, which is the linear speed, is what? Is the change in the linear distance with respect to time, because the linear distance here is going to be here, is going to change as we move, right? And also we have the angular speed, which is just the rate of change of the what? Of the theta, because as you move also, theta will also change. So two things are changing: the distance from here to here, as you can see. If we move this point here, the distance will extend to here. So as the distance changes, the angle will also change. So from the change of distance, we get linear speed. From the change of the angle, we get what? The angular speed. And we can always have, there's always a relationship between these two. So let's discuss this one first. What is angular speed? Angular speed is rate of change of what? The angle with respect to time. And we have, what is the unit of the angle? The unit of angle could be rad, right? So it could be rad per second. It could be rad per minute. And also we can even have it in revolution per minute. or revolution per second. But here we have to note that 1 revolution is the same thing as 2 pi rad. This is very important, conversion factor. For the linear speed, it depends on the speed. If s is in centimeter, you have centimeter per minute or meter, so I mean centimeter per second or meter per second. So, and we also have a relationship between these two, which we will use, right? So let's just discuss the relationship before we go. Now, we said that we know that V is equals to S over T, right? But what is S? S is what? R times theta. We discussed this one already, right? So this, you can see that this is R times, we can have theta over T here. But what is theta over T is our angular speed. So this is R times angular speed. Remember, we started with the linear speed. So this is a simple derivation of the relationship between the linear speed. So if you have the linear speed, and here is the angular speed, and what is R? R is the radius, right? Okay, we will use this formula. So now let's start to solve this problem. You see here, it says a boy rotates a stone in a what? In a 3 feet long sling. So this is there's a stone here. So if you rotate this, what happens? It will form a circular motion, right? So it's having how many revolutions? And this 3 feet is going to form the radius of the circle. The radius is going to be 3 feet because you have a rope. If you move it around, your point is going to be at the center, right? So from the center, it's going to start moving around. And that's from that center to the circumference is going to give you the radius, which will be 3 feet. And at what rates? At the rate of 15 revolutions in every 10 seconds. So we want to find the angular and linear velocities. So how do we find the angular velocity? Let's say we have remember the angular velocity is just what? Theta over theta per time, right? So here already we have how many revolutions? So this is like 15th revolution in every 10 seconds, right? 15. So here, what we can do is we can convert this revolution to radians. So we have our angle here is just going to be 15 rev, but we multiply by 2 pi. And just to take it to just to take it to radian, right? And then in every 10 seconds, the time is 10 seconds. So here, what have we done? We just converted We just converted revolution to radian by multiplying by 2 pi. Then we divide by 10 seconds, which is the time. So this is just going to give us 3 pi rad per second. So this is our angular speed, because angular speed is is theta over over t. So the theta here is 15. You multiply by 2 pi, it becomes what? It becomes 30 divided by 10. Now, when you multiply by 2 pi, you have converted revolutions to radian. Now, for V, which is kind of the linear velocity, right? We can find the linear velocity. And what is the linear velocity? Remember, it's S over S over T, right? S over T. So what is going to be S in this case? And if we remember, we can use S to be r theta, right? So we just have r theta, something like this. And what is that r here? Our r is, remember r is what? R is 3, right? R is 3 feet. Then we can just multiply by what? We can just multiply by this one. So this is just like we have 3 times what? 3 pi rad. And this should give us 9 feet per what? Per second. So it's just like, because if you say V is equal to R theta, what is theta over what? Theta over T is just nothing but what? But the angular speed, right? So you just need to multiply by 3 and we're done. But now you to be in feet per second because you are dealing with the linear velocity or linear speed. Okay, so let's try to solve this one. 13. It says a belt runs a pulley of what? Radius 6 centimeter. So if you're running a radius of 6 centimeter, so R is equals to what? 6 centimeter. Omega is 80 revolution, right? 80 revolution per watts per minute, yes. So we want to find the angular speed in radian per second. So here, angular speed is already given as 80 revolution per minute. You want it in rad per second. So we just multiply this by what? By 2 pi rad over what? 1 revolution. Because we know that what's, look at it, we know that 1 revolution, look at 1 revolution is equals to 2 pi rad, right? So if I'm looking for 80 revolution, let's call it x. So if I want to solve for x, what will be x? X will be 80 rev times what? 2 pi rad. But I have to divide by what? 1 rev, right? So that this rev will cancel this rev, yeah? Is it? So that is why here you can see we are multiplying by 2 pi rad, but I'm dividing by what? 1 rev. So that this 1 rev will cancel this rev, right? Okay. So, but now we still have minutes here. This is minutes. This minute also need to go to second, right? So we have to multiply also here by what? But I know that 1 minute is what? 60 seconds. So I will have 1 minute here. Then I will have 60 seconds here. Because the minute is what is in the denominator, so it needs to cancel out. So it means 1 minute, 60 seconds. So if you look carefully here, rev will go with rev. You have only rad, then minute will go with minutes. So omega now is going to be 160 pi rad over what's over 60 seconds. And now this is going to be 0 will cancel 0. So we have 16 pi rad over second. But there is divide by what? Divide by 6. Now if you divide by both sides by 2, we should have 8 pi rad over 3. But now it's in what? In per second. Then to find this linear speed, so the linear speed is nothing but we just use this one, right? But remember, we already have our R. R was 6 centimeter. So this is going to be 6 times what? 8 pi over 3. 8 pi over 3. And this should give us what? This should give us 16 pi centimeter per second, because this is linear speed. And the radius is in centimeter. Okay. Now for 14, it says each tire on a car has a radius. So the radius here is what? 15 inches. So the radius is 15 inches. And omega is what? 450 revolution per minute. Now we want to find the speed of the automobile in what? In inch per minute. So since we see inch per minute, what does that mean? You always look at what? Always look at the units. So we're actually looking for V. Because if it is W, you will see ref or rad, right? So we are looking for V. This is what we need. So the first thing we do is we can first of all convert our omega, which is 450 rev, but rev per what? Minute. So we just need to convert what? If you look at this, we need per minute. So you don't need to convert minute to second. You just need to convert revolution to rad by multiplying by 2 pi rad over 1 rev. And this will just give us 900 pi rad. Yes, but you still have per minute because this will go with this one. So this is just 900 pi rad per minute. Okay, then we can find our V, which is just going to be R multiplying by omega, which is the angular speed. R is in inches, so you have 15 inches. Okay, multiply by omega, which is what? 900 pi rad per minute. Let me put it down here. So if you look here, what is supposed to be the unit here? Now, one thing we know is that if you look at V, the formula, this is rad. This rad is going to disappear. You don't need to have rad. So I will explain that. This is just going to be 15 times 900. So which is 13500 pi. Then the inches will remain. Then what? Per minutes. Now someone will ask, where is this rad? Usually I explain this using this. Remember, if you have S is equals to R theta. So what is R? R is S over what? Theta. But what is the unit of S? The unit of S is always the same thing as the unit of the radius, right? So let's say if the radius is in inches, S will also be in inches. So it's going to be inches per what? But theta is always in rad. So you have inches per rad. So when we put inches here, actually, we can even write it as inches per rad so that this rad will go with this rad. So take note of that. That is why the rad always disappear, because it comes from here. The inches is going to be for per each rad, right? Each radian angle. So I think that is the end. And what next is the exercises. So thank you for watching. I hope this is helpful.